Again, welcome to Statistics. This is DSRT 734 class. In these lectures, we're going to discuss about hypothesis testing for variance and also standard deviation. We are going to use the chi-square table. So our main objectives here is how to find the critical values for the chi-square test, and also use the S-square test to test the variance or standard deviation. So first, finding the critical values for the S-square test, which we call the chi-square test. First, we have to specify the level of significance. That's the first step, the alpha. Then second step, we have to determine the degree of freedom, which is normally the sample size minus 1. Then we find the critical values for the chi-square distribution, which again are found in the chi-square table. To find the critical values for right-tail test, we use the value that correspond to the degree of freedom and also the alpha. And then to find the left tail test, we also use the value that correspond to the degree of freedom, but with alpha and 1 minus alpha. So again, right tail test, we use the value that correspond to degree of freedom and alpha. Then with the left tail test, we use the value that correspond to the degree of freedom and 1 minus alpha. Then with the two-tail test, we use the values again that correspond to degree of freedom and half times alpha, and also degree of freedom and 1 minus half times alpha. The reason why it's half alpha, we can remember the same concept we used in our previous proportion for two-tail test, or for the population mean for two-tail test. We have the left side and the right side. So if alpha is given, we divide alpha into 2, half for the left side, half for the right side. So with the right tail, we use degree of freedom and the alpha value. Left tail, we use the degree of freedom and 1 minus alpha value. With the two tails, that means both left and right, the left side, we have the half alpha with the degree of freedom, then 1 minus half alpha to the right with the degree of freedom. Again, we're going to solve an example soon. So again, finding the critical values for the chi-square test, we have a right tail here. So we have our SO square and the alpha for within. With the left tail, you go to the left side. And with the two tail, we have the, again, to the left will be half times alpha, but to the right also half times alpha. Again, we divide into 2. So let's see an example. Here they say we should find the critical x-square value for a left tail test when n is 100, when n is 11 and alpha is 0.01. So here all we need is the sample size and also the level of significance. Then we can find the critical x-square. So first we find the degree of freedom, which will give us n minus 1. N is 11 minus 1, so that is 10. Then here we have to look, we are looking for left tail test. So if it's a left tail test, the area to the right of a critical value is 1 minus alpha, which will give me 0.999. So this is our graph. We have the alpha is 0.01, so 0.01 here. The rest will be 0.99. Then now we go to the chi-square table. When we go to the chi-square table, the critical value will be 2.558. And the chi-square table, normally, the most important thing we need is, again, the degree of freedom. So if the degree of freedom is 11, then I will go to the 11 row. Then I'll look for the alpha value. The alpha is 0.01. So alpha at 0.01 with the degree of freedom, again, I'll get with the degree of freedom is 10, sorry. The sample size is 11, 11 minus 1 is 10. So with 10, and I'm looking at alpha 0.01, my answer will be 2.558. So again, to find the, again, using the chi-square to find the critical value, again, we use our degree of freedom, which is again sample size minus 1 is 10. The alpha is 0.01. If it's left tail, then we have 1 minus 0.01. So we have 0.99. So let's do the second question now. Find the critical S-square or chi-square value for a two-tailed test when n is 13, alpha is 0.01. So first we find the degree of freedom is 12, 13 minus 1. Then this time is two-tailed. So we know we have half alpha. Alpha is 0.01, so we get 0.005 and 0.005 to both left and right. Then we have to subtract 1 minus half alpha, which gives me 0.995. So now I'll go to my table, my chi-square table, and I will look, first of all, is degree of freedom is 12. So degree of freedom is 12. Our alpha is, half alpha is 0.005. So that will give me 28.3 in my table, but against roughly 28.2999. So again, we go to the 12th row, chi-square table, 12th row, and then this is two ways, so half alpha, half times alpha, 0.005, and that gave me 28.3, which is 28.299 here. So again, looking for the critical value with chi-square, two things we need: the degree of freedom, and always the alpha also is given. Now it depends, as we saw in the theory, if it's a left tail, right tail, and a two-way. So we say from the chi-square table, the critical values are, again, 3.074 and 28.299. So let's do the chi-square test. We say the chi-square test for variance and also standard deviation, for variance or standard deviation. This will be a stat test for a population variance or standard deviation. So this can be used when the population is normal. Then the test statistics is, again, S squared. This will be our variance. And again, the formula for the standardized test statistics will be n minus 1 S square divided by standard deviation square. So for the test statistics, we have standard deviation square divided by population standard deviation. This will follow a chi-square distribution with a degree of freedom n minus 1. So we have S square equal to n minus 1 times S square over standard deviation square. So in words, we state the claim mathematically and verbally. We identify the null and also alternative hypothesis. So we state the HO and HA. Then we specify the level of significance, that's we identify the alpha. Then we determine the degree of freedom and sketch the sample distribution. Then we have to determine the critical values, again, using the chi-square table. Then we determine any rejection regions. We find the standardized test, which again is the n minus 1 times standard deviation for the sample square, or we say the variance square, divided by variance for the population square also. Then we have to make our decision to reject or fail. hypothesis, the null hypothesis. So again, the standard test will be n-1 times the sample variance divided by the population variance. Also, we can use the standard deviation. So here we are using the variance. So let's see example. I think this may help us more. So here we have example. Here they say a dairy processing company claims that the variance of amount of fat in the whole milk processed by the company is no more than 0.25. You suspect this is wrong. And also you find that the random sample of 41 milk containers has a variance of 0.27. So this means 0.25 is what the variance that the company is claiming. And the dairy processing company claims that the variance of amount of fat in the whole milk processed by company is no more than 0.25. But you suspect this is wrong, and you took a sample of 41 milk containers, and you find the variance to be 0.27. At alpha equal to 0.05, is there enough evidence to reject the company's claim, assuming the population is normally distributed? Again, our goal here is we are testing variance. So we use the chi-square table. So first step, we saw we need to state our null hypothesis and also alternative hypothesis. The null hypothesis is what the company claimed. So we have, and the variance should be less than or equal to 0.25 or greater than for HA. Let's go back to the claim again. Here, if the company should have claimed that the process by the company is equal to 0.25, then we have a two-way test. But again, this is one-way test because it says it's more than 0.25. So if it's more than 0.25, then our HA will be more than 0.25. HO will be less than or equal to 0.25. Alpha was given to us to be 0.05. We know the sample size, so degree of freedom will be 41 minus 1. The sample size given was 41. This is normally distributed. So here we have our diagram here. Again, the alpha is 0.05 given. So based on the alpha value, we can get the S-squared value. But now we have to test it. So we find the S-square or the chi-square, n-1 sample variance divided by population variance, which the 2 is given to us. Actually, the claim of the variance is the population, so 0.25. Then when the sample, we get the variance to be 0.27. Our answer is 43.2. So 43.2 will fall under the blue section. 43.2 will be on the brown area, because we can see based on alpha equal to 0.05, we get our S-square line to be 55.758. So that's the boundary between rejection and also retaining. So the alpha here gave us the 55.758 boundary line between, to my right is rejection, to my left is to retain. So here we fail to reject HO. So we say at the 5% level of significance, there is not enough evidence to reject the company's claim that the variance of the amount of fat in the whole milk is no more than 0.25. So let's try a second example. Here we say the restaurant claims that the standard deviation in the length of serving times is less than 2.9 minutes. A random sample of 23 serving times has a standard deviation of 2.1 minutes. At alpha equal to 0.10, is there enough evidence to support the restaurant claim, assuming the population gain is normally distributed? So here the company's claim or the restaurant claim that the standard deviation, the length of serving time is less than 2.9. So first we need to state our HO and HA. If it's less than 2.9%, then we have greater than or equal to 2.9. So we can see our HO is, again, the standard deviation is greater than or equal to 2.9. So HA will be less than 2.9. Alpha is given 0.1. We know degree of freedom will be n minus 1. And the question, we collect a sample of 23, so 23 minus 1. Then we draw the diagram. Based on the alpha value 0.10, our S-square value will be 14.042. So we do our test statistics. Here we are using the, again, standard deviation. So you can see that if the value here is a variance, then we are just going to write the 2.9 because variance is already square. But the question gave us standard deviation. So you can see that 2.1 we square it, 2.9 also we square because 2.9 is standard deviation. The formula is variance for both sample and population. So when we do our calculation, we get 11.536. So we see that 11.536 will fall inside the blue, so we are going to again reject HO. So we reject HO. Another example here. Here we say a sporting goods manufacturer claims that the variance of the strength in a certain fishing area is 15.9. So here they gave us exactly value is 15.9. So here we are going to have a two-way test. A random sample of 19 fishing line spools has a variance of 21.8. The alpha is given to us to be 0.05. Is there enough evidence to reject the manufacturer claim, assuming the population is normally disputed? So here our HO will be again 15.9. So it's two-way test. 15.9 is HA, not equal to 15.9. Alpha is given to be 0.05. We know the sample size, so we can find the degree of freedom. Now let's draw our, it's two-way. So we know alpha is 0.05, so it will be 0.025 to the left, 0.025 to the right. And when we do this, from the table, we're able to get two values, 5.629, then 26.119. Then next, we find the test statistics, which is sample size minus 1, variance of the sample divided by variance of the population, which is 15 minus 1, 21.8 over 50.9. That give me 19.194. So 19.194 will fall within the brown area. So this time we are going to accept our HO, fail to reject HO, so we have to accept it. So here we say at 5% level of significance, there is not enough evidence to reject the claim that the variance in the strength of the fishing line is 15.9. So in summary, in these lectures, again, we went through how we can test our hypothesis using either variance or standard deviation. In this case, we have to use the chi-square table. So again, the steps are the same. Hypothesis testing. First step, we state our HO and HA. Then the second step, we know our alpha level. If we know the alpha or the significance level, we can draw the diagram, distribution diagram, and we can identify the boundary line between accepting and rejecting. It can be left tail, it can be right tail, it can be two-way. Always the two-way is when the HO is equal to a specific value. Then HO will be not equal, then it will be two-way. So after we do that, then we do our test statistics. The value of the test statistics, we will see if it falls within the rejection area in the graph or retaining area in the graph. When I say rejection, retaining means rejecting or retaining HO. Now, when we are doing hypothesis testing, always we are testing the HO. So our decision or interpretation of our decision should be either we accept or reject HO, not HA. So those are the steps. Again, hypothesis testing using standard deviation of variance, we use the chi-square table. And we have the formula for finding, again, the test statistics, which is, again, n-1 times the sample variance divided by the population variance. Again, thank you and wish everybody the best.